Welcome to homework.
So here in this problem we are given that there is a rigid tank that contains 3 kg of saturated liquid vapor mixture, and the pressure we are given as 200 kilopascal, and initially 3/4 of the mass is in liquid phase. This means that the quality of the water vapor is 0.25, or we can say that the dryness fraction is 0.25, and we have to calculate the entropy change of the steam during the process. So first of all, we will be calculating the entropy at state 1, and then at the initial state, and then final state. So in the final state, all the liquid in the tank is vaporized. Okay, so we'll be using the steam table A4 and A6 that is given in the book. So the state 1 condition is pressure we are given as 200 kilopascal, and the quality or the dryness fraction it is given as 0.25. At this value we'll be calculating the value of VF, VFG, SF and SFG from the table. So after obtaining a value, we can calculate the specific volume at state 1, and it will be equals to VF plus x1 times VFG. So VF is, from the table, it is 0.001061 plus x1 we are given as 0.25 times VFG is VG minus VF, so VG is 0.885878 minus 0.001061, and the unit is its unit is meter cube per kg. So we'll get the value as approximately 0.22224 meter cube per kg. So this is the specific volume at state 1. Now next I will be calculating the specific entropy at state 1. So it will be equals to SF plus x1 times SFG, and SF from the table it is 1.5302 kilojoule per kg Kelvin, plus x1 is given as 0.25 times SFG means SG minus SF. So SG is or we can write the directly value also from the table, it is given SFG also, and that is 5.5968. So after solving this, we'll get it as 2.92, and its unit is kilojoule per kg Kelvin. So we'll get 2.9294 kilojoule over kg Kelvin. So this is specific entropy at state 1. Now next I will be calculating the specific entropy at state 1. So we know that the tank is rigid, that means the specific volume will remain constant. So V2 will be equals to V1, and that is 0.22224 meter cube per kg, and X2 it will be 1 because it is saturated vapor. So from these two values we can calculate the entropy at state 2 from the table, and it will be 6.6335 kilojoule per kg Kelvin. Now next we can calculate the entropy change of the steam during the process. So delta S, that is the entropy change, it will be M times S2 minus S1. So mass we are given as 3 kg in the equation, and entropy we have calculated as, this one is S2 is 6.6335 kilojoule over kg Kelvin, minus S1 is 2.9294 kilojoule over kg Kelvin. From here we'll get the value of delta S, approximately 11.1 kilojoule over Kelvin. So this is the final solution. I hope you got the problem. Thank you.